Hi there, this is the second video of epsilon delta proof of a function is continuous on a point. And I already explained the intuition behind the definition, so I won't do that in this video. You can go check the previous video. So let's get to the solution. I always start by saying let epsilon be positive, okay? So because in the definition I have let epsilon be positive, so whenever I'm on this interval, so here the a is -2, so whenever I have x minus -2, which is equal to x plus 2, is less than delta, so I'm checking, can I find such delta that whenever this holds, do I have fx minus fa, here -2, less than epsilon? Would this hold? Can I find such delta for each epsilon? So let's start with this definition, fx minus f minus 2. So I have fx being equal to x squared, and f of -2, so if I put -2, it will be -4, and if I put -2, it will be +4, and I have minus from this part, okay, so it will be x squared minus 4. And now I can do difference of two squares, and I can say this is x plus 2 times x minus 2. So from the definition, I know that x plus 2 is less than delta. So I can say this thing is less than delta. Less than delta. But I don't know about this part. So I can say this is less than question mark, and I can just try to find it. And in the end, I can say this is less than delta times question mark. So I'm trying to find an upper bound for x minus 2. The classic way would be to say, so I have x minus 2, and I want to find an upper bound. So what do I have is x plus 2 is less than delta. So let's try to make this similar to x plus 2. So I'm adding plus 2 and subtracting 2. So it will be -2 minus 2, it will be -4. And now I can use the triangle inequality, which says I can separate this thing from, I can separate it like this. Okay, let's write it in one more step. I can say this is equal to x plus 2 in the triangle inequality. If I'm adding two stuff, okay, this will be less or equal than both of them separately added in absolute values. X plus 2 minus 4. So now I can just say this is equal to x plus 2, and absolute value of -4 is just 4. So now I have something similar. I can say that absolute value of x plus 2 is less than delta. This is from the definition. So this is less than delta plus 4. So now I can say this question mark is just delta plus 4. And I'm almost done. So I have something not so complicated. So the first way, from here I will give you two options. The first way is to say this is equal to epsilon and try to find delta is equal to something like a function of epsilon. Okay, this is not same function. Can I find such function g? Okay, so let's see how can I do it. So I'm saying delta squared plus 4 delta equal to epsilon, and I will try to separate this delta and find what is delta in terms of epsilon. So this looks like something expansion of a square, so I can complete this to a perfect square. I can say this is delta plus 2 squared, and I need to add plus 4, so I just add plus 4 to right side too, so this is epsilon plus 4. And now if I just square root of both sides, I know that this thing is positive, so I can just do that. I can say delta plus 2 equal to epsilon plus 4 in the square root, and now I can just add -2 to both sides, so this delta is equal to epsilon plus 4 minus 2. Also, you should in general check that does this make sense, because the conditions we have for delta here, I didn't write it, but of course this is positive. Okay, so is this true? Is this greater than 0? Yes, because I know that epsilon is greater than 0, so this thing is just 4. So I can say this inside is greater than 4. So I can say the square root is greater than 2. And so if this thing is greater than 2, I'm just subtracting 2. This thing will be positive. So this delta is correct. And I can pick delta. Let's write it a bit more left. So this is my first answer. So this is the solution. And now I will give you a second way to solve this. This method may not work all the time, because here we had something simpler. It was delta squared plus 4 delta, and we could easily leave the delta alone, and we could solve it for delta. But it could be something a bit more complicated, and we need a bit more generalized way, like a bit easier way to solve this. Okay, so here, if you look at this part, I had x plus 2 times x minus 2. Let's look what can I do. What is this? So I had x plus 2 times x minus 2. And I already know that this is less than delta, so I didn't know anything about this part. So I'm saying let delta be less than 1. So this is the most famous trick we use. Okay, most of the times we pick it just being less than delta. And also in the previous video we discussed like, can I actually pick delta being less than something, because I don't know anything about delta. It could be bigger or equal than 1, but we can do this. But in the end we should consider this fact. Okay, so what do I have is that I have x plus 2 is less than delta, which is less than 1. Actually, I have less or equal. Okay, so I say less or equal than 1. And so now I can just, this is also greater than 0. This is always true. So I can say x plus 2 is between 1 and minus 1. And so I can just add minus 2 to both sides, or I can just add minus 4, because I need this thing. Okay, I need an upper bound for x minus 2. So I'm just adding minus 4 to both sides. So I have minus 5 less or equal than this x minus 2. And so I add minus 4. This is less or equal than 3, minus 3. So now if I just take absolute value of this thing, well, we need to be a bit careful here. So I know that this is greater or equal than minus 5. This is the bigger bound, absolute, in terms of absolute values. So I can say this thing is less or equal than absolute value of 5, which is 5. This would always be correct, okay? Because it's between 3 and 5 if I think it like positive, because it's same, okay? I could say this is like this. And I only need this part. So I know that this thing is less or equal than 5. So I have that this thing is less than delta, and this is less or equal than 5. So in the end, it will be less than 5 times delta. Sorry if the 5 and delta looks a bit similar. And now I can say this is equal to epsilon, because now I have something much simpler than saying delta squared plus 4 delta being equal to epsilon. Because now I can just say delta is equal to 5 over epsilon. Sorry, epsilon over 5. And like we discussed at the first video, so now I can just say delta is equal to epsilon over 5. I need to pick delta minimum of, so I bounded it with 1 here, okay? So I need to consider this 1 and epsilon over 5. Because now I know that this thing is less or equal than 1 and less or equal than epsilon over 5. And whenever both of these satisfy, I will know that my function fx minus fa will be less than epsilon. And that's the end of it.